A very good day to all. Today I'm going to demonstrate you for the simulation of the process as given in exercise 2.1. So this process is basically to remove hydrogen from the hydrocarbon stream before the hydrocarbon is subjected for a further separation in the downstream using a series of distillation column. So removing hydrogen is important because the hydrogen is a very light gas that will actually occupy a lot of space in the unit op. So we can easily separate hydrogen from the hydrocarbon stream using a flash drum. So what you need to do is you have to create a blank simulation. Okay. Once you create a blank simulation, you'll be guided to the list of components. So this is the first information that you have to put in. So we have hydrogen. So always put the component through the third column under the component name. Okay. Hydrogen, we have methane, we have ethylene, and we have ethane in the feed stream. So once you have done this, you can name your component. Say hydrogen, I would like to name it as H2. Then we have CH4 for methane. Sorry, CH4 and CH4 for methane. Name. You just put any name that you like, but don't put the name that will confuse yourself. Okay. So I put it as the molecular number. At least I know from C to H4 I know it's ethylene, and from C to H6 I know this is ethane. Okay. So with this, if you don't know which step to go, just click next button here. Next. You'll be guided to a page for you to select the property method. So we have to use Arcsoft as mentioned in the question. Arcsoft is good for hydrocarbon system. And actually under common method we just can't find Arcsoft. So you have to go to all. So just choose all under the method filter, and then you choose Arcsoft. Here is it. Okay. Once this is done, just click the next button, next again, to generate all the required information for the properties. So with the statement of table generation completed, with the status of results available, then we can proceed further to the environment of simulation. So we are under the properties environment, just shift to simulation environment. Okay. So before we start putting in more information, it is always a good practice for you to save your file. Just save as backup file and name it accordingly. So you can name it as probably exercise 2.1. So once this is done, then you can include more information and it will be auto-save. So go to the separator. Under separator model palette, so we have flash tool. So just put in the stream. So red color arrow is the location that we must put in the stream. So put the cursor on the red color arrow, then you put in the stream accordingly. Right? Okay. Now you can select the flow sheet and then Control B to realign all the stream. Okay. It looks more tidy now. So you can also rename your block V101. Just use the correct convention for flash vessel. So it starts with V. So with this, of course, you can click next, or you can go and include the feed specification and also the unit operation specification. So no worry, if you don't know which step to go, just click next. So this is the area for you to include the feed information. So as given in the question, all the unit given is actually in British unit. No worry, just go to unit sets here, unit sets on your top left. So you change it to English unit, and now if you look at the temperature pressure is in Fahrenheit and PSIA, and like molar flow is pounds more per hour. So all this is British unit. Okay. So as given in the exercise 2.1, the PDF file, the details for feet is minus 90 Fahrenheit, and the pressure is 475 PSIA. So in terms of flow composition is given in terms of mass flow, pounds per hour. So the mass flow for hydrogen is 6,300. Then we have methane, about 29,500. We have ethane, about 26,000. Right? And then we have the last one, ethane. Now is ethane. Just now is ethylene. Okay. So total we have about 67,500 pounds per hour. That is the total feed. So just next, this is the place for you to put in the unit operation specification. So as given in the question, pressure is 472. Okay. 472. But we have to first put in pressure and also vapor fraction, because that are the given information initially. Pressure and vapor fraction. So vapor fraction is 0.514 because the hydrogen fraction in the feed is 0.514. So we assume that only hydrogen is in vapor phase. The rest is in liquid. So the vapor fraction is 0.514. So I think we have all the information for the base case simulation. We have included the feed specification as well as the flash vessel specification. Let's click next, and then the message confirm that you have all the required information, and click OK. So once this is done, so it is always good to have the results available without error, without warning. Okay. If the results turn up with error or warning, then you have to troubleshoot the simulation. Okay. So now no problem, because it is results available without any warning and error. What you need to do is go and check the stream information. So under the block of B101, the flash vessel, so go to stream results. So this is the place for you to check the stream composition. So we have the S2 is the vapor phase, vapor product, and S3 is the liquid product. Right. So in terms of mole fraction, so for hydrogen, the vapor, hydrogen mole fraction, and then the hydrocarbon, the liquid stream, hydrogen mole fraction. So as stated in the question, the criteria for the hydrocarbon stream is it shouldn't have more than 0.02 mole fraction of hydrogen. If you check this, so we fulfill one of the criteria. So you can check the details for the other criteria. So I think that's it for base case simulation. Okay, before we end, I think I'm going to show you. So in order to check the results for the unit op, so you can go to again V101. So under the results tab, just click. So here you can check all the information, like what is the temperature pressure of your unit, okay? and what is the duty required for your restaurant. Okay. I think that's all. Thank you very much.